Hey everyone, welcome to another ALEKS tutorial video. In this one, we're going to be deciding whether a Lewis structure satisfies the octet rule. So, there's two questions we want to ask for this problem, and that is, does the element satisfy the octet rule? And if it does, are there the correct number of valence electrons? So let's start with this first one. We have a carbon and we have an oxygen. So each one of these, this is a triple bond here, and triple indicates 3. And so in each bond there are 2 electrons. So each one of these lines represents 2 electrons, and we want to see if each element satisfies the octet rule. So we have one lone pair for the carbon, so that's 2 electrons, plus another 2 electrons, another 2 electrons, and another 2 electrons. That's a total of 8 electrons. And so we can say that carbon satisfies the octet rule. And oxygen has a lone pair over here, and those same 3 pairs of electrons. So oxygen 2 has satisfied the octet rule. What about the valence electrons? Does it have the correct number of valence electrons? Well, to figure that out, we need to see what group each element is in. So, carbon is in group 4, meaning it has 4 valence electrons. And oxygen is in group 6, meaning it has 6 valence electrons. So, 4 valence electrons and 6 valence electrons gives us a total of 10 valence electrons. That's how many it should have. So to see if that matches, we just need to count up how many valence electrons are in the whole compound. So we have 2, 4, 6, 8, and 10. So, the question asks us, is it a reasonable Lewis structure? In this case, the answer is yes. Drop my pen. Okay, so moving on to the next one. So let's see if every atom in this compound satisfies the octet rule. So we have, for this fluorine atom, we have 2, 4, 6, 8. That indeed satisfies the octet rule, so we'll put a little check by that one. Now we have our oxygen atom. We have 2, 4, 6, 8. That indeed satisfies the octet rule. And finally, we have our last fluorine over here, which has 2, 4, 6, 8. And once again, this satisfies the octet rule. So what about valence electrons? So if we look at the periodic table, we can see that fluorine is a group 7 element, and that's paired with an oxygen, which is group 6. So if we have 2 fluorines, that's 7 times 2, and that is 14 valence electrons plus our oxygen, and that gives us a total of 20 valence electrons. So we need 20 valence electrons in this compound. So how many do we have? We have 2, 4, 6, 8, 10, 12, 14, 16. That's definitely not right. So this is double check. 2, 4, 6, 8, 10, 12, 14, and 16. Yep, that's not right. We should have 20. So what do we put for our answer? Well, it's not this one, because we actually, yes, it is that one. Sorry. I was going to say it's not this one, because we have the right number of valence electrons, but it doesn't satisfy the octet rule. It's not this one, because we don't have the right number of valence electrons. Sorry about that. So, this is true, this statement. And then it wants the correct number of valence electrons. Well, we found that to be 20. So you would just put 20 in there. So moving on to our next one, we have 2 hydrogens and an oxygen. So remember that hydrogen is an exception to the octet rule, where rather than having 8 electrons surrounding it, it should have 2. So, does this satisfy the octet rule? Well, our first hydrogen has a total of 2. So, indeed, this satisfies the octet rule. Our second hydrogen has 2, 4. That's impossible. So, this hydrogen does not satisfy the octet rule. And then our oxygen has 2, 4, 6. It shouldn't. It should have a total of 8. This does not satisfy the octet rule. So, moving on to our answers, does it have the correct amount of valence electrons? Well, we already know we're not going to select this answer because we've already found out that it doesn't satisfy the octet rule, so we know that's going to be our answer, but just for the heck of it, let's check. So, we have 2 hydrogens. Hydrogen is in group 1, so we should have 1 valence electron plus 1 valence electron for our second hydrogen, plus our oxygen, which is a group 6, so that'll have 6. So this should be 8, right? And we have 2, 4, 6, 8. So it does satisfy the right number of valence electrons. But it does not satisfy the octet rule. So, no, it does not satisfy. And the problem atoms, for this one, you just want to write out, separated by commas, each one that doesn't satisfy the octet rule. And it says down here, if there's more than one of the same one, just separate them by commas. So in this case, we have a hydrogen and we have an oxygen that doesn't satisfy the octet rule. So our answer down here would be H, comma, O. All right, hope this helped. Thanks for watching.